Before we get into the percent change formula, I'd like to discuss some things that I consider 8th grade math, stuff you've learned in elementary school and probably have since forgotten. So I want to talk about sales and tax and how to find the final cost after each of these events. So let's start off with a store having a 30% off of everything sale. What we want to find is the sales price, not necessarily the final cost, but the sales price of the item, which costs $150. So the 8th grade style was this. You take your 30%, you change it into a decimal, so that would be 0.30. You would take that 0.30 and multiply by $150 to find out how much you're going to take off of your price. My only problem with that is you're usually not interested in how much you're saving. You really should be interested in how much you're paying. But we'll do it 8th grade style anyways. So we're going to start off with the percent as a decimal, multiply by the $150, and this will equal, let's see here, 0.3 times 150, $45. So your savings is $45. And this is where they try to catch you because they're like, oh, you'll save $45, you'll buy the item. But you really should be more interested in how much it's actually going to cost you. So to find the cost, the 8th grade style, now you have to take the $45 away from the 150. So 150 minus the 45, that leaves you $105. So it's still going to cost out of your pocket $105 before tax. All right, so the other way of doing it is what I consider the one-step process. Let's look at it algebraically. So wherever you see this 150, the price could be anything. So we're going to replace that with, let's do G. There's a reason for using G later on. So wherever I see 150 in these calculations, I'm going to replace it with G. So the item now is going to cost G dollars. All right, so you would take the 30% of G, oh, that was messy, G, there we go, and you would take this away from the original cost, which was G. All right, a little side note, algebra. If you have 2x plus 7x, most of you can answer that the answer is, well, 9x, and you'd get it right. But then I would ask you something silly like, what's ax plus bx? And that usually confuses students because they're like, well, a and b aren't numbers. Well, if 2 and 7 weren't numbers, pretty much the idea is this. What would you do with the 2 and the 7 to come up with the 9? So basically what happens is you recognize that they both have x's, you ignore the x's completely, you add the 2 and the 7, and you come up with the 9, and then you throw the x back into place. The reason this works is called the distributive property, also known as factoring. So what these two have in common are the x, so I'm going to kick it out, factor it out, and what's left behind after you divide away the x is a plus b. So in here goes a plus b. And I can show you that this actually works by doing the same thing up here. 2x and 7x have that common variable x, so I can kick it out. Left behind is 2 plus 7. And of course, 2 plus 7 is 9, and that x kind of just hangs out, which is the exact same answer as down here. It's actually the distributive property when you combine things with like terms. Well, here you have like terms, g, and the number in front of g is 1, so what you can do is you can kick the g out. It's a horrible g. And left behind is this 1 minus 0.3. I'll write it as 0.30 because most people will. Alright, so then this becomes 0.70 times g. So another way of doing this, let's put the 150 back in for g, is to take 70% of $150. And if you take 70% of $150, it brings you right to your answer of $105, the final cost of the item. So instead of doing two calculations up here, finding the percent or the markdown value, and then subtracting that away from the original cost to come up with your cost, your sales price, you can do one calculation up here quickly, 1 minus 30%, and come up with 70%, and then just multiply and get your answer. But this is of more interest to me right now, this part of the process. But we'll hold off on that for just a second, and we'll come back to this step. But for finding sales price, this is actually the quicker way. If it's 30% off, you subtract that from 100%, and you take 70% of the value to find your sales price. All right, let's look at tax. In Edgecombe County, the tax is 7%. 2.25 goes to the county, and the rest goes to the state. Find the final cost of an item that costs $150. All right, 8th grade style. You would take the 7%, change it into a decimal, divide by 100. You would multiply the cost of the item, and this will tell you how much tax you're paying on the item. So let's see here, 0.07 times 150. So $10.50. So you would owe the government $10.50 just to buy that item. All right. Then you would turn around and take the original cost, $150, and add on the tax, $10.50, to come up with your final cost. How much is going to cost you to get out of the store with this item? So $160.50. And again, there's a shortcut way of doing this. Just like before, go through and take the 150. We'll replace it with a G, and this one also. And do the exact same thing. Take the 7% of G and then add G back. So you get something that looks like G plus 0.07 G. And just like before, you would factor out the G, and left behind will be a 1 from the G over here plus 0.07. So 1 plus 0.07. So the quick way of finding tax would be to take 1.07 and times it by G. So if you do 1.07 times 150, your answer will come out as $160.50. So again, a one-step process to come up with your final cost. Now, of course, this process ignores how much tax you're paying. It just tells you how much you're going to pay totally. All right, but again, this part I'm actually more interested in. All right, so let me explain the more interested in. To get to the percent change formula, G I'm going to consider as my old value. I use G for grandma, but old looks like a 0, so I replace it with G. And I'm multiplying it by this reduction. This is a price reduction. Write that in there. Price reduction. And because it's a price reduction, you're always going to have that minus sign in there. So it's always 1 minus whatever the percent is. We can give any letter we want to a percent, but the formula that I write down usually is x over 100, right? So this would look like 1 minus x over 100 times g. And what it's going to equal is a new value. Here the new value was a sale price, n. So when it's a percent decrease or a price reduction, x being a percent, so if it was 5%, I would put 5 over 100. If it was 20%, I would put 20 over 100. If you're going to change your percents into decimals anyways, just get rid of the 100 part of it and write x as the decimal percent. But this is the formula I usually work with. Oops. Oh, where is it? There it is. So we're going to work with this formula. All right, so that would be a price reduction. Back to tax. It looks about exactly the same. Here we have a plus, and here this is because it's a price increase. So if you have an increase, you're going to have a positive sign in here. If you have a decrease, it's going to be minus. And of course, you multiply this together and you also get this new value. Down here, the new value is your final cost. So the formula here, and I'll write it in the right order, new is equal to grandma times 1 plus x over 100. So let's see how this formula works. Your boss is going to give you a 15% raise. Isn't that nice? You currently earn $12 per hour. How much will you make after the raise? So this is going to use the formula new is equal to grandma times 1. Since you're getting a pay increase, it's going to be plus, and then the x over 100. Alright, so that's the formula we're going to use. Now we're looking for the new value, your new pay, so we'll leave that alone. G, of course, is your old pay, which was $12 an hour. And then we're going to have 1 plus the 15%. And because I'm leaving the 100 in the formula, I'm not going to write it as 0.15. I'll let the calculator do the work here. So to find the new salary, it's going to be in money, of course, and I just type this in the calculator exactly the way it looks, including the parentheses. So let's see here, 12 parentheses 1 plus 15 divided by 100, and then hit enter. So now you will be making $13.80 an hour per hour. And that's how you would find your raise after a 15% increase. Alright, let's look at a decrease version. I just made this up, so I don't know if it makes any sense, but hey. There is a 4.3% decline in the number of homeless after a housing mandate by the city. There used to be 1,334 homeless in the city. How many are there now? So again, this is going to use basically the same formula. New is equal to grandma. We're going to have 1. But because this is a decline rather than an increase, it's going downhill, this is going to be minus 4.3 over 100. And again, I'm going to let my calculator do all the work so I don't make any silly mistakes. Ooh! Back up. I've been writing that as x so far. X over 100. And then we'll substitute in our numbers. So I don't know my new value, so n. Grandma is the old value, which is the 1,334, and it's going to be 1 minus 4.3 over 100. And type that exactly the way it is into the calculator. Parentheses 1 minus 4.3, 4.3 divided by 100. And we end up with 1276.638. Now, if you're going to answer this question, you have to make a decision. There's no such thing as 0.638 of a person. So you either have to take this number and round it down to the 1276, or you round it up to 1277. Now, neither one is right or wrong. So generally, when I ask you a question like this, I'll tell you how to round it. Generally, I have you round it up. But there are some cases where you actually want to round it down. So there used to be 1,277 homeless. Let's take this formula and manipulate it one more way. Finding new and grandma is actually not that hard, but sometimes what's of interest is the percent change itself, this x. So I want to take this formula and actually algebraically solve it for x. Once we get there, though, it's going to be another formula that we can use under certain conditions. Alright, so let's start solving for x. The first step is, distribute. So we're going to bring the g into this expression. It's not going to look pretty, but that's okay. So we're going to get n is equal to g times 1, which is just g, and then g times x over 100. And I'm going to write it as g times x over 100. This is totally legal. Alright, now remember, our focus is trying to solve for this x here. We want to get this by itself. So we want to take as much of the other junk and shove it to the other side. And what I consider junk in this case is everything that's not an x. So the easiest one to move, of course, is this big capital G. So I'm going to subtract G from both sides. And that's going to give me new minus grandma, which has its own fancy name, I'll tell you about that later, is equal to grandma times x over 100. Alright, so I still need to get things away from x. Well, the next thing I can get rid of is just this g. Now where I subtracted this g across because it was being added on to the right-hand side, this one is connected with multiplication, so I have to do the opposite. Well, the opposite of multiplication is division, so I'm going to divide both sides by g, grandma, and I get this ugly expression on the other side. It is kind of bad, of new minus grandma over grandma is equal to x over 100. So we're getting closer. The x is almost by itself. Well, the last step is pretty easy. You just have to multiply both sides by 100. Now, whether you multiply by 100 or just remember to change things by multiplying by 100 is up to you. But the technical formula is x, the percent change, is equal to new minus old, in this case grandma, over old, grandma, times 100. And then, of course, you have to tag on a percent sign, otherwise it'll just be read as a number rather than as a percent. So you're not taking 100%, you're just doing this calculation over here and putting a percent at the very end of it. So here you'll end up with something like 0.05. After you multiply by 100, it turns into 5%. Alright, let's see how this one works. New minus old over old is another way of writing it, but I'll keep with the G for old, grandma. So the number of students at ECC was 2,159 in the fall of 2014. The number of students at ECC in the fall of 2015 went down to 1989. What is the absolute change? That's that first step that I wanted to talk about. And the relative change in the student population from 2014 to 2015. So the formula is this. It's x, the percent change, is equal to new minus old over old times 100, and then don't forget to tack on the percent sign. Alright, so in this case the new value is the more recent one. That would be your fall of 2015, and there were 1989 students, so that's going to go in place of new, 1989. The old number is the previous value, which was 2,159. So that's going to go here, 2,159. But that's also going to go in the denominator. So we're just going to copy it over again, 2,159. We'll do that calculation, multiply that answer by 100, and when we write it on our paper, we're going to tag on a percent. Alright, now be careful with this calculation. If you type it in exactly the way it looks, kind of, on a piece of paper, it would be 1989 minus 2159 divided by 2159, and then if you multiply by 100, which is really bad, you get 1889, which really doesn't make any sense because that's 1,000%, almost 2,000%, and it hasn't really gone up that much. If it's a 100% increase, it would just double. It would just double. So you got to be careful. This long fraction bar here is an old notation for parentheses. That means if there's two pieces either above or below this, you have to put it in parentheses first. Now, if you don't like using parentheses, the trick is do the calculation on the top, get an answer. Divide by the bottom, get an answer. Multiply by 100, and then write it as a percent. So 1989 minus 2159 is 170, negative 170, over 2159 times 100, which change to a percent. Now there's a reason I'm putting this step in here. We'll talk about that in a second. So let's just finish it off on the calculator. Divide by 2159 times 100. This turns out to be negative 7.87 if I round to the nearest hundredth of a percent. Now the negative here represents a percent decrease, kind of like a sale. But I haven't answered my two questions. I went through and used the formula that I just created, so it seemed like a natural step. But these two questions are actually kind of important. The first one is absolute change, and all absolute change is literally new minus old. So the new minus old answer is right here. It's that first step. Subtract the two numbers, the new one minus the old one, and come up with this absolute change. So in this case, the absolute change is 170 students, decrease. So your number of students has gone down by 170. The relative change is exactly what we found as a percent. So the relative change is exactly this finding the percent change in from the old to the new, that percent change, that x. So in this case, x is your relative change. So in this case, it's a percent decrease of 7.87% is your relative change. So in absolute change, you just subtract the new minus old. The relative change, you have to go through the percent change formula to find out the percent decrease or the percent increase.